recording. We're on 2.5 online help session. This is problem number 20, and it's talking about an object being thrown downward with the initial velocity of 6 feet per second. What is relationship distance s? Let me turn that down a little bit. It's gonna be loud. Yeah. So let me move this. I don't know where I can move that. All right, let me move this down. It's given by s equals 6t plus 16t squared. So normally I would write it like this: 16t squared plus 6t equals, they want to know how long does it take for it to fall 76 feet. So 76 feet is an output, right? Because they told you distance s, right? And the 76 is a distance because the t is a time. So all you got to do is really just 16t squared plus 6t minus 76 equals 0. By moving it over to the left-hand side, now you have a quadratic. The easiest way to solve a quadratic is just to, if it doesn't say use factoring, it's just the quadratic formula, right? So A equals 16, B equals 6, C equals negative 76. So it's negative B plus minus square root of B squared plus, oh, not plus, sorry. All over 2A, right? Yeah, I got to get this up here. There we go. So if we do this, we're going to plug, when I substitute these things in, I want to make sure that I'm putting them in parentheses so that I know that if it's a negative, like especially with the B right here, when you go negative B, if that 6 was negative, a negative makes a positive, right? So that's a common mistake. And then another mistake that people make is this. You've got, so that's negative 6 plus minus square root. And I'm going to show you some other things too to kind of help you, to verify your answers and to make sure that things are right. 6 squared is 36, right? Now, when you do the minus 4 times A times C, I do this. I do negative 4 because I take that subtraction and apply it with it. So I go negative 4 times 16 times negative 76. Get my calculator. And if you can tell, that negative 4 and that negative 76 is going to give you a positive result because 2 negatives make a positive. And I got 4864. So that would be plus 4864 all over 32. And then we would do that. We'd do negative 6 plus minus. Let me get this. There we go. Good. That's better. Let me get back to here. Square root of, what's that? Plus 36. So that's 4,900. And you can tell that 4,900 is a perfect square, right? Because 49 is perfect square and double zeros, well, that's multiples or times 100 or 1,000, right? So you can kind of look at that. Now this is going to, I'm going to bring this back over here. I'm going to change to blue. So I got negative 6 plus minus. I'm going to take the square root of 4,900, right? And what that gives me is 70 over 32. So x is equal to, I say x, it should be t, right? So, because that's time, right? Uh, what you're going to end up having on this, on these type of equations, just to kind of keep in mind is this: you'll have a positive value and you'll have a negative value. Okay, and when we get to doing this on the a tool that I'll show you here to help you to do this, it'll make a lot more sense. So what I'm going to do is I'm going to say t is equal to -6 plus 70 divided by 32. And then I'll say t is equal to -6 minus 70 divided by 32. Um, and then this right here would be 64 divided by 32, which is 2. And then this is -76 divided by 32. Um, and that's negative 2.375 seconds. And we know we can't do this one because we can't have negative time, right? So the time it takes for it to go to reach or fall 76 feet is 2 seconds. It takes 2 seconds. Okay. So what I want to do is this. I want to show y'all a really cool tool that you can utilize to help um, investigate these quadratics. Okay. And they'll help you to validate your answer as well. Because the thing about this is, yeah, you got to solve it. You got to solve by factoring, right? You also have to solve by quadratic formula. We will not complete the square, okay? So if it ever says complete the square, solve by completing the square, the quadratic formula is a formula-based complete the square. Okay, that's how it's derived. So, but I want to show you a really cool tool. Um, and this is called Desmos, right? Now it's a tool, not a way to get an answer. I mean, I could sit here, if I wanted to, I could sit here and I could take a picture of the problem on Photomath, or I can take the picture of the problem on Mathway, or what's the other one? That burn it. Um, it's got more and more now. But anyway, um, I could I could do that. But that doesn't teach me how to do the math. It only provides me an answer. Okay. Um, so uh, let me get to that problem again. I want to. Okay, it's 16t squared plus 6t. Okay, so let me move this. I'm gonna go 16. I'm gonna type it in. Um, p caret top, right? Squared, and then arrow over. Um, plus 6t. Oh shoot, I hit equal. Sorry. Plus 6t. Okay. Um, that's going to be in one of them, and then the other one, um, I don't want that. We'll set that equal to 0, and then I'll take this one. And we wanted to know how long it took to hit, what, 76 feet? So we could do 76 and just hit enter. And what you should do, why is it doing that? We can only support explicit equations x, y. Okay, so you can't use t. Sorry. Backspace x, backspace x. Let me move this over. All right, there. Let me. Now let me just do this. Minus 76. Just put the whole thing in there. Um, take that off. All right. So if I go here, um, let me move this over. And I click here. Why is it giving me that? Oh, I know why. I'm missing the 16. Thank you. Okay, good. Um, so if you just graph it, you can look at this, and that's really what it's saying. Because when you move the 76 over and give the quadratic, you're actually saying where's it crossing the x-axis, right? When you set it equal to 0. Because when your output 0, that's when y is equal to 0, so it's your x values. And so we got 2, right? And we also got negative 2.375. Okay, so that's really what it's doing. And you can validate. You just type it in, graph it, and it'll, as long as it's set equal to 0, it'll tell you those points, right? It'll validate what you've got. And it's a really good tool, Desmos is. Um, so I recommend you using it if you want to check your answers and stuff like that. It's a really good tool. Okay. So, and just to kind of get used to doing some things, because graphically, um, you don't have a graphing calculator, right? Most of us, we carry, don't, a lot of our students don't get a TI-83, a TI-84 or whatnot, but Desmos is online, and as long as you can type that in, it's great. I want to do this because I also want to show you something. 16x squared plus 6x, right? And then 76, right? And what I should have is a line. Let me make this one go away. We go up here to 76. We should have a line. Y equals. There it is. So if I put y equals 76, I don't know why it didn't take it without it. If you look right here, 2 and then 2.375, right? So that's by separating it, like you putting in the first equation and then you put in the second one. That second one's a horizontal line, so you can kind of treat it like that as well. But the easiest way is just to do it like you got right there. But we got the same answers, right? 2 for the x value and then negative 2.375, right? So just something to kind of think about. Okay, all right, so where you want to go to next? I probably just blew your brains on that, or your minds, so sure can we look at 16. Okay, solve the answer, use a factoring of the quadratic formula, whichever is appropriate. Make sure to simplify your answers. All right. What approach did you take to begin with? Let me move this over. Yeah, I got it. For this one? Yeah, this thing's about to take a picture of the whole screen, so give it just a second. I don't need it to do that, but it sometimes it does that. So um, there we go. Let me go to this one, and then I can just grab here. Um, we know we got to have two answers, right? It says solve using factoring or the quadratic formula, right? Whichever is appropriate. Okay, so we got two factors equal to a number. All right. So let's investigate this. Let's see if there's an easier way. Majority of the time, here's what you would do. Majority of the time, you'd say, okay, let's distribute this, right? A times A is A squared. A times 1 is A. 4 times A is plus 4A. 4 times 1 is 4, right? And then set it equal to -1. Combine like terms, we get A squared plus 5A. If I move this over, this becomes a +1, +1, so that becomes 5, right? And then it's equal to 0, and then we just solve it as a quadratic, correct? So, you got A equals 1, B equals 5, C equals 5. All right, so any questions about what I've done thus far? Okay, I want to make sure that I'm recording too. Okay, good. Because I'm gonna work this two ways. I think it may work the second way, but I want to definitely make sure I do it this way. Okay, so we go -5 or that 5 squared minus 4 times 1 times 5 all over 2 times 1, right? So that's -5 plus minus 25 minus 20, right? All over 2. So I get -5 plus minus square root of 5 over 2, right? So that's, I say x, it's really a, right? But let's see this. So now we're at the point where we can split this, correct? We've got x is equal to -5 plus square root of 5 over 2, and x equals -5 minus square root of 5 over 2. Do you see how I'm breaking these up? How I'm splitting these? Yay or nay? Okay. So what I'm going to do is I'm going to get a decimal. Okay. So I'm going to go -5 plus Isaac. Come turn this lamp on for me, please. Square root of 5. And then dividing by 2. And I get this. I get a x equals -1.382. And then if I do -5 minus, make sure I did, yeah, square root of 5, enter, divided by 2, I get this. I get x is -3.618, right? Now, that's what I got. And those are answers, right? So I could put those in right here. But I want to see something. I don't know if this is it will work, and it probably ain't going to work because just looking at it, I can go ahead and tell you it ain't going to work. I would something, if I did this, that's not going to work. Setting each factor equal to -1, because if we were to do that, that would give me -5, and that right there would give me negative -2, right? So this option is not going to be an option, okay? You cannot do that. It's only when you have them set equal to 0 that you can do the 0 property. So I just wanted to work this out, verify that that's that. But I will give you a really cool thing. Watch this. Ready? This is pretty cool. A plus 4, A plus 1. Watch this. We go. X, I have to use that, right? And then X plus 1, right? Equals -1, right? Yeah. So I got -1.382, and guess what I got right here? -3.618. Isn't that what I got just a while ago? Let's see. It sure is, isn't it? See what I'm saying? So the Desmos, I really like Desmos to check things, right? Now you're not going to have Desmos on the final exam because you have to do yours going to be paper pencil, it'll be multiple choice, but it can really check your answers to verify that what you've got is right very quickly. Okay, and all I did was type it in exactly the way it was, right? And I'm looking at my zeros. There you go. So it's a very powerful tool, but you can solve it. You need to know how to solve it, right? So there. Um, okay. Any questions on this one? Okay. Have y'all ever been exposed to Desmos? Have you ever worked with Desmos before? It's pretty powerful. Um, the state of Georgia in their end of course testing, uh, the calculator that is online for the kids to use on the math part is Desmos. So, and that joker would do it'd do anything, but you got to know what you're looking at and how to put it in. So, I want to kind of go through some things right here, maybe just to point out. Um, that one's pretty easy. Get it back equal or that 6 back over, right? No big deal about that. We'll talk about this one because I want y'all to kind of see this. It says solve the quadratic by factoring, right? And then I'll teach, just kind of re-emphasize some things just to make sure that you understand that there's different looks if it says solve by factoring. Um, all right. Note, okay, so I go ax squared plus bx plus c, right? Equal to 0. I want to make sure y'all understand this one is called the quadratic term, right? There you go, brother. Linear term because it has a power of 1, and then c is the constant, right? Where there's looks when it says factoring, solve by factoring, that if you understand what they're giving you, um, there's certain approaches that you can do that are easier. Okay, so if huh? Yeah, yeah. If you okay with me working this? You know how to do it, or okay? So what we're going to do is, you remember solving squared equations? That's exactly what we're going to do. See, we've got a quadratic term and a constant. So we're going to solve by what's called the square root method. And sometimes they'll look like this, right? All I do is take the 25 over to the other side, just so you can kind of see it traditionally. It may look like the black here or the green here. If that's so, you got the quadratic term, you got a constant. What you want to do is you want to, again, get the constant over to the other side, divide by the 4, so it leaves you with x squared equals 25 over 4. Now, how do you get rid of a squared? You take the square root. And when you take the square root here, um, note that 25 and 4 are perfect squares, right? And note that you can split a fraction underneath the radical by putting it as a radical over the numerator and radical over the denominator. And in doing that, you have 5 what? Plus or minus 5 fourths, which would be, if you looked at it as decimal, be 1 plus minus 1.25, right? So if it ever said solve by factoring and it gave you a quadratic term and a constant, then what I would do is I would use the square root method, okay? Oh, yeah, sorry. Yeah, you're right. My bad. You're right. Yes, it would be a 2. Square root of 4 is 2. Thanks, appreciate that. So it'd be 5 halves, which would be plus minus 2.5, right? And if you type that in just like that on Desmos and looked at your x's on your x-axis, it'd be 1 at 2.5, it'd be 1 at negative 2.5, right? But when you go to solve this, it says solve by factoring. So if you got a quadratic term and a constant, it's called the square root method, because really all you're doing is solving a squared equation. Okay. So that's a hint on that one. All right. Let me show you a little bit. If you got any questions on this one anymore? Yeah. When you get into it on when you're looking at this will make a little bit more sense. Ani, are you good on that? Okay. That one's pretty easy. No, that right there, same thing. Quadratic term, constant, square root method, right? When you divide it by 2, you have x squared equals 16, so you should know that that's plus minus 4. Trying to think. No. Oh, okay. I'll take 17 off. That's just ridiculous. Okay. It's just decimals. I mean, if you can solve it with whole numbers, you don't need to be solving it by no decimals, okay? That's just ludicrous. Let me make a note there. 2.5, number 17, remove. Okay, go ahead. Sorry. What number was it? Oh, complete the square? Oh, um, I showed that. Um, okay, so let's you want to do it on this one? I can do it on this one. It's not too bad. Or I can, it's 14, 13. Uh, no, I tell you what, it'd be easy to do it on. It's easier to do it on probably this one, right? Let me show you what I was talking about. Okay. Yeah, it's more theory. It's they say complete the square, right? They teach you back in high school how to complete the square, which is if your coefficient of your quadratic term is 1, you take half the linear term, square it, add it both sides, and you've created the perfect square trinomial, right? And then solve it from there. So I kind of want to let me show you this. This is I don't expect you to do this, but I'll explain a little bit more. Um, so if I do this and make this x by x, then this becomes what? X squared, right? Okay, and by completing the square, it says take half the linear term. So half of 9 is what? 4.5, right? Negative 4.5. The process, and then they say, you know, square it, right? I'm going to move this over to, and so that's going to be negative 20. So I'm going to move that, make that negative 20. So when it says take half of it, so really what you're doing, and I'm just going to do it with these blocks. This right here is really uh, minus 4.5, right? Okay. So when you do the complete the square, you square this negative 4.5. The reason you square it is you're finding out what this little green box is, right? Because think about the side. X minus 4.5, x minus 4.5. If the sides are the same, you have a square, right? Yeah, the sides on a square are the same. So right now, that's what we have by the process of complete the square. You know, it says take half the linear term and square it and add it to both sides. Well, the squaring part of it is because this little red box right here, its value is minus 4.5, minus 4.5. So if I want to know what this right here is, it would be negative 4.5 times negative 4.5, right? Which would give me, this would be 20.25, right? So I would add 20.25 to both sides because I've added it to make the perfect square here, which would give me, here's the perfect square trinomial, and negative 20 plus that gives me 0.25, right? And then you just solve it from there. So that's x minus 4.5 equals, that would be 1/2, right? Square root of a quarter, 0.25 is 1/2. And it'd be plus and minus, right? Um, so that would give me, if I added 4.5 to both sides, that would give me x equals to 4.5 plus and minus 1/2. So I'd go 4.5 plus 1/2, which is equal to 5. And then I would do 4.5 minus 1/2, which is 4. So here's my answers. So that's completing the square using um, the theory of it's algebra tiles is really what it is, right? In terms of that, but um, it's a visual representation. The quadratic formula does all of this, so you don't have to worry about it. Okay. Right. You'd have to factor out uh, the coefficient from the quadratic term and the linear term, and then you could do it from there. So it's just easier to say just do quadratic formula. But that was what I was going over was doing that. Um, but if you ever get taught this and have the opportunity to really practice over days and doing this, shoot, you can solve any quadratic formula just like that using the algebra tile technique of completing the square, and it works. I took 8th graders and they solve quadratics using it like this by completing the square. They could do it quicker than I could do it by solving it by the quadratic formula. Um, so it works. It's really cool. It's a lot of theory in there, but it's the practical application of how it works. But I'm not going to expect you to do this because, again, the quadratic formula is nothing more than complete the square, right? It's a formula-based complete the square, so don't worry about it. So, with all that being said, there. If I were to type in 5 and 4 here, I'd get it right. So, all right, I'm trying to find one else, just to kind of, no, not that one. I was looking for one that's got a quadratic term and a linear. No, boy, there's some, you can see how to do those, right? Are y'all good with factoring? Like factoring a quadratic? Like this? All right, so let me teach you how I do some things, okay? This says solve by factoring, so therefore you're going to be able to solve it by factoring. I use an X, okay? Now, this is what I mean by X. I do an X. Now, there's some things that go in here. So I'll put that. The number that goes in here is A times C, and the number that goes in here is B, okay? Because, all right, so let's look at this. We've got A is equal to 1, B is equal to 1, C is equal to negative 42, right? Okay. So A times C, 1 times negative 42 is negative 42, right? That's what goes up the top. A times C, right? Now the B was 1, correct? So what I want you to understand is we have two little boxes over here that we're going to solve for, right? So these two little boxes must multiply to give me negative 42, but they must also add to give me the 1, the B, right? That's the whole theoretical basis behind factoring. Two things that multiply to give you A times C, but when they add together, they should give you the linear term. Okay? So you can, I want to talk about this real quick. This is negative 42, right? So what you want to do is you want to find all the factors of negative 42. Now, because this is a negative, you're looking at the difference of the two factors, okay? If it was positive, then you would be looking at the summation, the addition of the two to get the B, right? So here's how I do this. Okay, I start out at 1. 1 times 42 is, guess what? 42. Now, I don't worry about it being a negative, okay? Because the negative means I'm just going to take the difference. The next number after 1 is 2. Will 2 times something give me 42? Yeah, 21, right? Now, will 3, let's see, 42 divided by 3? Yeah. So 3 and 14, right? The next number is 4. 42 divided by 4? Nope. 4 won't go. Next number after 4 is 5. 5 definitely won't go. 6 will. 6 times 7, right? And then the next number after 6 is 7. I've already crossed over. The number that I'm needing next is already over here on the other side. So therefore, I know that I need you to, hold on guys for a second. Okay, so here we go. Um, so that's how I find every factor of a number. I always start at 1, and then I go to 2, then 3, 4, 5, all the way up to the number that the next number is the number that's on the other side, right? So I told you that it's negative, right? That I'm looking for a difference. So this difference would be 41. This difference would be 19. This difference would be 11. And then this difference would be what? 1. And that's what I'm wanting. So I'm needing 6 and 7, right? But if you do 6 times 7, I get a positive 42. But I need a negative 42, right? So in order to make this a negative 42, but when added together to be 1, I need to make the 6 negative so that it makes this be true. this is the whole premises behind factoring. I have to find two numbers when multiplied together would give me A times C, and then I have to, those same two numbers when added together have to give me the B. Okay, the reason being is that's right. Yeah, this the sign of B will always be the biggest number. Okay, so if B was positive, so the bigger number has to be positive. If this one was negative, then the 7 would have to be negative, right? But as you can tell, you can very quickly see that negative 6 plus 7 is positive 1. Negative 6 times 7 is negative 42. You see that, right? So because this A is a 1, then I can do this. I can go and put them straight like this, right? Straight as factors. And then I can use the zero property, which means you take each factor and set it equal to 0, and then you would add 6. So x equals 6. And then over here, x would equal negative 7, right? So that's factoring. I found by factoring that it would cross this quadratic cross at 6 and it cross at negative 7. Okay. Um, what you're doing, I teach grouping if this A was something other than a 1. And what I mean by grouping is it's this. So I want to show you something. X squared 42. Let me do this. Is that minus 42? Yeah, it is. Okay, so these numbers right here that I've got right there, if I were to combine these would give me a plus x, right? Would y'all agree? Yay or nay? If I were to take 7x and negative 6x because they are like terms, and if I were to combine them, it would give me a positive 1x, right? Do y'all agree that? Okay, so what you're doing when you're finding these numbers right here, let me do this. When you're finding these numbers right here, what you are actually finding is the numbers that are, if you were to split the linear term, those are the two numbers that would give you the linear term if you were to split it. Does that make sense? Yeah, that's exactly right. I could substitute 7x and negative 6x in, because if I combine like terms, it would still give me a positive 1, right? So that's you're unsplit with grouping, which is another technique, and I showed it on the video. Grouping is splitting the linear term. So I want to show you this real quick while I got you. Um, so if I were to rewrite this, it would be x squared plus 7x, and then minus 6x minus 42. Now grouping says I've got four things, right? So what I'm going to do is put parentheses around and group them. That's why they call it grouping, right? So I want to pull out the GCF. Okay, GCF. The GCF is either a number, a variable, or the product of a number and variable. Okay, a number could be just a number, or it could be just a variable, or it could be the product of a number and variable. Okay, so just looking at this first parentheses, the only thing, I can't pull out a number, right? But I can at least pull out a variable. And if I do that, that makes it x plus what? 7, right? Now, once you get this parentheses fixed, the other parentheses has to follow suit. It has to be that. Um, Now, what would I need to do to negative 6 to get it to be just x, right? I'd have to pull out a -6. Because if I put out a -6 from -42, I get a +7, right? So if you think about this, I'm right back to where I was in the very beginning, right? The two parentheses are the same. They go right here to make one, and then the outsides combine to make the other parentheses. Now you go, that's just so confusing. Well, it's really not. Okay, you've seen this. It's called FOIL. Okay, when you group them and you're factoring out by GCF, what you are creating is the FOIL of that binomial. Okay, and FOIL means first, outside, inside, last, right? So I want you to think about this. Okay, so if I take this one and I'd multiply those two, right, by FOIL, right? And then I would take this one and multiply it by those two, correct? Y'all with me? Have I have I lost you? Yes. Okay. What I did was this is um, what I did right here. I just when you use the grouping method, which is a technique that you use when the coefficients other than a +1, use grouping. What you're doing is you're splitting the linear term, and when you split it, you end up with 4 terms, right? So you group them, put 2 in this one, 2 in that one, and then you GCF the first one. And um, when I GCF the first parentheses, I couldn't pull out a number, but I could pull out a variable, and the variable is x, and I pulled it out. But once I get this first parentheses, the second parentheses has to be identical to that, right? Um, so I asked myself, what do I need to do to -6x to make it just x? I need to pull out a -6, right? And if I say -42 divided by -6, I get a +7. And what that leaves me is this. And if I were to set those equal back equal to 0 like we had earlier, um, so I'd get x equals 6, and if I were to do this, I'd have x equals -7, right? So that's what I got up here in the very beginning anyway, right? Correct? I didn't have to do grouping because my coefficient here was a 1, right? That was a 1. But if it's something other than a 1, then I need to, after I do this x right here, after I find these 2 yellow highlights, then I'll need to unsplit the linear term, and that's what this is, and then do grouping. 2 parentheses, GCF it, and everything. But grouping, you've seen grouping because it's really the premises of FOIL. And what I mean by FOIL is this. If I were to tell you to take and multiply these 2 binomials together, this is really what you would do, wouldn't you? You'd take it and do it like this, right? Correct? So I want you to see something. I've done x times x plus 7. Watch this. And then I've done -6 times what? X plus 7. Wait, when you multiply a binomial, that's really what you're doing? Yeah. Which is, guess what, guys? Nothing more than reversing group. It falls right back into grouping, right? Right. That's why these become the 2 factors. That's why the ones on the outside become a factor and the ones on the inside are a factor, right? Because of binomial multiplication, and grouping just falls right into it. So that's, FOIL's first, outsides, insides, and then the last, right? Well, if you multiply, if you do this, that's really what you're doing, right? Which is what this is doing when you're using grouping. You're just kind of reversing the multiplication. Okay. So, yeah, that's probably a lot to chew on. So, just look at that, kind of go through. You can Google solve factoring by grouping, and I'm pretty sure I showed grouping in one of the videos anyway, right? Yeah. So it works. Grouping's probably traditionally the most one if this A is not a one, right? But this is what I use if it is. All right. Um, Anything else out of here? I'm gonna take off number 17. Um, let's look at number 18 real quick. I haven't looked at it. Um, Discriminant. Y'all know what the discriminant is, right? That's correct. B squared minus 4AC, right? What that tells you is if it's a positive number, then it's going to cross the x-axis twice, right? If it's equal to 0, then the vertex of that quadratic is setting on the x-axis. And if it's a negative number, then you know you're imaginary, which means it will not cross the x-axis. Okay, so that's what the b squared minus 4ac on this, right? The b squared minus 4ac is the discriminant, right? Um, that's what it tells you. If it's greater than 0, then it's 2 real. If it's equal to 0, it's 1 real. And if d is less than 0, it's 2 imaginaries, right? So that's really when you're solving it by the quadratic formula, that's really what it's giving you information wise so that you know um, what your answer should be, right? Uh, so it's kind of like a cheat code before the final answer, right? Okay, y'all good? Bad? Overwhelmed? Yeah. Watch the video. It's solving quadratics, right? Solving by factoring, solving by grouping, and some word problems. It's a meat and tater one, but I'm telling you, it is. Uh, this is one of the biggies as far as the content in college algebra. You've got to be able to solve a quadratic, right? And you can use Desmos to, to check your answer, not to do the problem for you. You know, I mean, I've had students um, that they just take that computer and they um, snap a picture of Photomath, or they use Mathway, or what is that other that's been around forever and a day? Um, Wolfram, right? Wolfram. Or they'll type it in and they'll solve it by Wolfram, and it's just like if if that is your approach, then when it gets to the final exam, which is 30% of your grade, you're going to get slammed. You're not going to know what to do it, right? So um, anyway, so there, that's 2.5. So you've got the video, you've got me going through some stuff that is kind of looking at some different things. So just kind of note that you need to buckle down and do it. You've got Desmos. I've showed you Desmos how to check, right? So and know that 2.6 is modified, so it's a little bit less, right? So that'll be a little bit easier for you. All right, y'all good? Y'all are really quiet tonight, so um, get in there, watch those videos, okay? It's important to watch it before you come and do this. That's why I split it up into every night as opposed to trying to do all of this in one night. So this and last night's stuff. Okay, y'all good? All right. So use Desmos to check. All right, and then watch the videos, and I will take off number 17. So, all right, that's all I got. Okay, thank y'all for attending. See you tomorrow. Bye.